Picture this, a massive machine, powerful and precise. This is the hydraulic hammer. Now, what makes a hydraulic hammer so special? It's all in the name, hydraulics. This technology uses fluid power to do work, and in the case of hydraulic hammers, that work is heavy-duty construction. These machines use the principles of hydraulics to generate a force that's both incredibly powerful and remarkably precise. Hydraulic hammers are not just any regular tools. They're the heavyweights of the construction industry, used for tasks that require some serious muscle. One of their most important uses, driving piles into the ground. Imagine trying to push a long, hefty pole deep into the ground. It's not an easy task, right? But for hydraulic hammers, it's a piece of cake. They can drive piles, whether they're made of steel, wood, or concrete, deep into the earth with ease. This makes them invaluable for building foundations, bridges, and other structures that require solid, stable support. Spun piles are the silent stalwarts of construction. They may not get much recognition, but their role is vital. Think of them as the unsung heroes, the supporting cast that makes the star performance possible. Spun piles are cylindrical concrete piles, manufactured through a process called centrifugal compaction. This process involves spinning a mold filled with fresh concrete at high speed, creating a denser, stronger pile. The result? A pile that's robust, durable, and ready to take on the mightiest of constructions. These piles are used extensively in foundation work. When a construction project needs a solid base, be it a skyscraper, a bridge, or a highway, spun piles are often the go-to solution. They're driven deep into the ground, reaching for the solid strata beneath the surface. It's a little like anchoring a ship, but instead of holding a vessel in place, these anchors support entire structures. What makes spun piles so special is their remarkable strength and durability. These piles can handle massive loads and resist environmental factors that can weaken other types of piles over time. They are unaffected by soil type and groundwater conditions, making them a versatile choice for various construction scenarios. The manufacturing process of spun piles is a fascinating one. It begins with a mixture of cement, water, and aggregate, which is poured into a steel mold. This mold is then spun at high speeds, causing the concrete to press against the mold walls, resulting in a dense, strong pile. The pile is then cured or left to harden before it's ready for the pile driving process. This pile driving process is where the hydraulic hammers come into the picture. These powerful machines exert massive force to drive the piles into the ground. It's a sight to behold, a symphony of power and precision, all aimed at creating a strong and stable foundation. With these spun piles ready for action, it's time to see how hydraulic hammers work their magic. It's time for action. The hydraulic hammer and spun pile meet in a dance of power and precision. The process of driving spun piles with hydraulic hammers is truly a marvel to behold. This is a three-step ballet of strength, accuracy, and engineering prowess, beginning with the setup, moving through the pile driving process, and ending with the finalization of the pile in the ground. So let's start from the beginning, shall we? The setup. This is where everything is put in place for the performance. The spun pile, a cylindrical concrete pillar with a hollow core, is positioned vertically on the ground where it is to be installed. Precision is key here, as the pile must be placed exactly where it's needed for the structure it will support. Next, the hydraulic hammer enters the stage. This isn't your everyday hammer, mind you. It's a tool of immense power, capable of delivering thousands of pounds of force with each strike. A crane lowers the hydraulic hammer until it's poised above the spun pile, ready to drive it into the ground. Which brings us to the second act of our ballet, the pile driving process. The hydraulic hammer springs into action, delivering powerful blows to the top of the spun pile. Each impact drives the pile deeper into the ground, a process that's repeated until the pile is at the desired depth. This is a show of raw power, but it's also a display of precision and control. The operator must ensure that the pile remains straight and true, adjusting the hammer's blows as necessary to keep the pile on course. Finally, we come to the last act, the finalization of the pile in the ground. After the spun pile has been driven to the desired depth, it's time to secure it in place. The hydraulic hammer delivers a few final decisive blows, ensuring that the pile is firmly embedded in the ground. Once this is done, the crane lifts the hammer away, leaving the spun pile standing tall and strong, ready to support whatever structure it's destined for. And there you have it, the process of driving spun piles with hydraulic hammers. It's a dance of power and precision, a ballet of engineering and construction that takes place every day on construction sites around the world. It's a testament to the skill and expertise of the operators who control these powerful machines and to the engineers who design and build the structures they support. And just like that, with a combination of power and precision, the spun pile is securely in place. One hydraulic hammer is impressive. But what about two working in tandem? Think of it as a symphony of power and precision, a duet of destruction and creation. Two hydraulic hammers, each a marvel of engineering in its own right, working in unison to drive spun piles into the earth. It's a sight that's as awe-inspiring as it is essential to the world of construction. This isn't just about doubling up for the sake of it, though. There's a method behind the madness, a reason why two hydraulic hammers might be set to work side by side. Imagine the scenario: two hydraulic hammers, each poised above a spun pile. The hammers descend, their impact sending vibrations through the ground. It's a process that requires a high level of coordination. The operators must time their strikes perfectly, ensuring that the hammers hit their respective piles at the right moment. It's a dance, a delicate balance of power and precision. Why go through all this trouble? Well, the benefits are manifold. For one, using two hydraulic hammers simultaneously can significantly speed up the process of driving spun piles. This means projects can be completed in a shorter time frame, saving both time and money. But it's not just about speed. This method also allows for a more even distribution of force, reducing the risk of damage to the piles. The simultaneous impact of the hammers helps to ensure that the piles are driven straight and true, a crucial factor in the stability of the finished structure. However, coordinating two hydraulic hammers is no easy feat. It requires skilled operators, precise machinery, and a deep understanding of the physics involved. But when done right, it's a testament to the incredible feats of engineering that are possible in the construction industry. Driving spun piles may be a complex process, but with the power of hydraulic hammers, it becomes a feat of engineering excellence. So what have we learned about hydraulic hammers and spun piles? Quite a lot, actually. First off, we've seen the raw power of hydraulic hammers in action. These mechanical behemoths deliver forceful blows that can drive piles deep into the ground, making them a crucial tool in construction. We also delved into the unsung heroes of construction, spun piles. These cylindrical structures are made with high-strength concrete and steel, providing stability and support to a variety of infrastructure projects. We then took a closer look at the process of driving spun piles using hydraulic hammers. It's a complex procedure that requires precision, skill, and a lot of power. But when done right, it creates a solid foundation that can withstand heavy loads and adverse conditions. With the knowledge you've gained today, you can better appreciate the engineering marvels that are hydraulic hammers and spun piles.